First, you try to understand in this video about the homologous series. What is homologous series? Okay, homologous series. Homologous series. It is a series of compound having same general formula. Okay, in which successive member differ by CH2 group. Okay, let's take an example. Example of homologous series: alkane. Alkane. What is the general formula of alkane? CnH2n plus 2. This is the general formula. Okay. In this, if you put n is equal to 1, put n is equal to 1, what will get? C1H 2 into 1 plus 2. That is equal to CH4. Okay. Put n is equal to 2. What you will get here? N is equal to 2, you put C2H 2 into 2. That is 4. Yes or no? 2 into 2 plus 2. That is equal to C2H6. Similarly, if you put n is equal to 3, you will get a C3H8. If you see the difference between these two, there is a difference of 1 carbon and 2 hydrogen. Okay, 2 minus 1, 1 carbon, 6 minus 4, 2 hydrogen. Yes or no? Similarly, you see here C3H8 and C2H6. 3 minus 2, how much? 1 carbon, 8 minus 6, how much? 2 hydrogen. So it is a series. Now, what is homologous series? Homologous series is a series of compound having same general formula in which successive member differ by CH2 group. Okay. Okay, this is only homologous series. Okay, we have other is also there when we talk about alkene. Talk about alkene. Alkene is also a homologous series. How it is? Alkene formula you see. Alkene formula is what? CnH2n. CnH2n. Put n is equal to 1 actually. So we will get C1H2 into 1, that is equal to C1H2. Actually, first member of alkene does not exist. Okay. So you take n is equal to 2. What will put? We'll get C2H, 2n means 2 into 2. That is equal to what? C2H4. Yes or no? C2H4. Put n is equal to 3. You'll get a C3H2 into 3. That is equal to C3H6. If you see, okay, there is a difference of 1 carbon and 2 hydrogen. Yes or no? See, 3 minus 2, 1 carbon, 6 minus 4, 2 hydrogen. Correct or not? Put n is equal to 4. What will you get? C4H2 into 4. What is there? C4H8. Okay, you can see again, there is a difference of 4 minus 3, 1 carbon and 8 minus 6, 2 hydrogen. Okay, so alkene is also a homologous series. Alkene. So what is a homologous series? It is a series of compound having same general formula. General formula is same in which successive member differ by CH2. Okay, so this is homologous series. Now we'll see the properties and definitions of homologous series. Okay. Alkane is a homologous series. Alkene. Yeah, yes or no? The definitions are there and properties are there. You can see. Okay, definitions. Homologous series. A group of organic compound having similar structures and similar chemical properties, and the successive compound differ by CH2 group. That is very, very important. There are certain characteristics like each member of the series differ from the preceding one by the addition of CH2 group or by 14 atomic mass unit. You see here, CH2 means what? If you want to find out the molecular mass of CH2, okay, carbon atomic mass is how much? 12. Hydrogen is how much? 1. So 1 into 2, how much? 2. So 12 plus 2, how much? So there is a difference of 14 atomic mass unit between the successive member. Is it clear? Next, all the member of homologous series share the same general formula. Okay, the physical properties of the members changes gradually. Okay, physical properties like a boiling point, melting point, they will keep on changing. Okay, a state also. For example, when you see alkane, okay, first 4 member are gases. Okay, n is equal to 1 to 4 are gases. Next up to 17 they are liquid. and after 18 their wax is solid. Okay, similarly here also we see the physical property will change. Next, all the member of homologous series can be prepared using the same general method of preparation. So how you are preparing the methane? Like this is methane. What is a methane? This is what a ethane. C2H6 is what ethane. This is what a propane. Okay, we'll see the naming also. How to name alkane? You see. Okay, alkane. Alkane. What is the general formula? Tell me. General formula is CnH2n plus 2. General formula is what? CnH2n plus 2. Here we are using the suffix. What suffix we are using? ANE. What we are using? ANE. Suffix we are using ANE. Okay. Okay. See, for example, if you put n is equal to 1, if you put n is equal to 1 in this, you will get what? A CH4. Okay, you should understand for different n we use some root word. N value is there and we'll use some root word. Okay, root word. For n is equal to 1, we are using method. We are using method. For n is equal to 2, we are using eth. For n is equal to 3, we are using prop. Okay, similarly, n is equal to 4, we are using but. N is equal to 5, we are using pent. Okay, so I'm substituting n is equal to 1. So 1 carbon is what we will use? Meth. Yes or no? Meth. What is the suffix we have to use? ANE. So what is this? Methane. What is a methane? Put n is equal to 2. What you will get? C2H2 into 2 plus 2. C2H2 into 2. That is 4 plus 2. Remember one thing, in alkane, hydrogen is 2 more than 2 times. If carbon is 2, hydrogen is what? 2 to 4 plus 2, 6. So 2 for second carbon, what is the root word we are using? Ether. So we write ether and suffix is what? ANE. So ethane. What is this? Similarly, you put n is equal to 3. Okay, so what you will get? C3H. 3 to plus 2, 8. Okay, yes or no? So for 3 carbon, what is the root word we are using? Prop. This is what a propane. What is a propane? Yes or no? Similarly, n is equal to 4 you put. So C4H. 4 to 8 plus 2, 10. So this is what is the root word? Butane. So we have to use butane. What is a butane? How to draw the structure? That also I'll show you here only side by side. See you. Carbon is there, right? Carbon. It has single bond only. 1, 2, 3, 4. Substitute the 4 hydrogen. 1, 2, 3, 4. Ethane, you see. Carbon, 2 carbons are there, right? Right, 2 carbons, single bond between them. In case of alkane, only single bond is there. And you have to fulfill the tetravalency. It means you have to make 4 bonds. 1, 2, 3, 4. With this 1, 2, 3, 4. So you see 1, 2, 3, 4, 5, 6. This is the structure of ethane. Yes or no? 2 carbon and 6 hydrogen. Similarly, you draw for propane. What is the formula? C3H8. Write 3 carbon. 1 carbon, single bond, 1 carbon, single bond, 1 carbon. And fulfill the tetravalency. 1 bond is there, 2, 3, 4. With this 1, 2, 3, 4. With this 1, 2, 3, 4. And substitute the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, in this way we can write this is propane. What is a propane? Is it clear? That's all for today's class.